Alright, let's look at the homework 7, problem number 28. Alright, so we have a function given, f of x is equal to 2x quantity x minus 3 cubed. Alright, so let's answer these questions. What is the domain of the function? Alright, so this is just a polynomial function. Domain is all real numbers. Let's see, you type in interval notation. Alright, so it's going to be start from negative infinity. Let's see if I have to click on infinity to positive infinity. I'll just put the infinity here. Alright, infinity. Alright, so let's check the answer. Alright, we got that. Alright, next one. What is the Y-intercept? Alright, so when you try to find a Y-intercept, you plug in 0 for x. Alright, so let's do that. Actually, we can do that too, right here. If you plug in x equals 0, alright, so the whole thing becomes 0. So f of 0 is 0. So there's Y-intercept is going to be simply 0. Alright. Alright, let's check the answer. Alright, we got that. Alright, next question. What is the what are the x-intercepts? Alright, so in order to find the x-intercept, we set the y equal to 0. It's always the other guy, setting that equal to 0. Alright, so let's do that. And if you can see that if you set this guy equal to 0, then we know that we can make x equal to 0. Right? Well, we can make x minus 3 equal to 0, which means that we can set x equals 3. So it's going to be just a 0 and a 3. Alright, so let's type it in. Alright, so we have 0, 3. So 0, 3. Alright, so let's check the answer. Alright, we got that. Alright, then let's see, what is the local maximum and or maxima if there are more than one, and let's do that. Alright, so here, alright, oops, in order to find the local maximum, we need to find the derivative first. Alright, so let's find the derivative so that we can find critical numbers. Alright, f prime of x. Alright, first thing is just 2 is just a number, so that's just a number, so I'll just put 2 there. Right. Then I'm going to use a product rule because we have two things. So this is the first guy, this is the second guy. Right. So derivative of x, so I probably need to put a bracket or something here. Right. Derivative of x is 1. Right. Multiply by the second guy, which is x minus 3 quantity cubed, plus first guy is x, times derivative of the second guy would be put 3 in front and keep the same quantity inside and subtract 1 from the power 2. Then multiply by derivative inside, which is 1. So I'm not going to write that because it really doesn't do anything. So we have that. Alright. And first, we're going to, before we set it equal to 0, we're going to pull out the common factor. So 2 is already out. All right, you see that there's x plus minus 3 squared, and they're actually cubed. There are 3 of them, so I'll just circle this so that I know that there's another x minus 3 sitting there. So we can pull out x minus 3 squared, right? Then what's left from the first term would be x minus 3. And what's left from the second one is positive 3x. Right? Then we just clean up a little bit. So we have a 2 times x minus 3 squared. Then we have 4x, putting x and the 3x together, minus 3. Right? So we got that. Right, so we set that equal to 0. Alright, so it looks like we know that we're going to get the critical numbers. So x is going to be equal to All right, so first guy, we can set this guy, x minus 3 equal to 0, so x equals 3, all right? And we can set the 4x minus 3 equal to 0, so what's that? Maybe I should do it here. 4x, so I'm going to get those, minus 3 equal to 0, and we can easily solve for x, right? Add 3 to both sides, so you get the 4x equals 3, and then you can divide it through by 4 to isolate x, so you have a 3 over 4. All right, so those are the critical numbers, all right? So these are critical numbers, right? And we want to make sure that you're going to have let's see, a local maximum or local minimum. Let's see, let's read the question again. All right, so the local maximum is at, okay, so we're looking for the x value where local max and local min is, all right? So it's going to be at 3 or 3 over 4. We don't know yet, so we have to make sure. All right, so we're going to do the number line here. All right. Then I'm going to put the critical numbers, 3 over 4, so I'll just put it here. 3 over 4 there, all right? And x equals 3, so I'll just put maybe a 3 here, all right? So here's the x, all right? And we're interested in f prime, and we just need to know the sign. All right, so we just have to pick some sample number, all right? Before 3 over 4, we can try maybe x equals 0, right? After 3 over 4, we can try x equals 1. And after 3, we can try x equals 4, right? We just need to know the sign, so we don't have to know the actual value, right? So we're looking at the derivative, so it's probably easier to look at this guy, right? All right, one thing we can do is here, 2 is already positive, so it's got the square there. So this guy, this part is always positive, right? So it just depends on the sign of that guy, right? So plug in x equals 0. So 0 minus 3 is negative, so this is going to be a negative sign there, right? If you do 1, and 4 times 1 minus 3 is actually positive, so you get a positive sign here. All right, and x equals 4, it's still going to be positive. All right, so you can see that here, it's a decreasing here and an increasing. So you're going to have a local minimum here because it's a decreasing turned into increasing. So we're going to have a local minimum at 3/4. All right, so let's type it in here. All right, and here x equals 3/4. All right, let's check the answer. All right, let's see. Critical value, and did I mess up the value here? Not sure. All right, hold on a sec, please. All right, I just didn't read the question. They're asking for a local maximum. Right, in this case, we actually don't have a local maximum, so we just have to click on that. And so I have to get rid of this guy too. All right, so here, and this is going to be, there's no local maximum. I was looking at the local minimum. All right, let's check the answer. All right, we got that. All right, then local minimum is at 3/4. All right, then check the answer. All right, we got that. All right, next question. And what are the inflection points? Select the correct choices. All right, so we have to look at the second derivative. So let's do that. All right, first derivative is already there. So we're going to take another derivative. So f double prime of x is equal to, all right, so 2 is just a number, so I put that there. All right, then we're going to take the derivative using the product rule again. right? Because you can see that this guy times that guy, so it's a product rule, right? Derivative of the first guy is 2 times quantity x minus 3, and subtract 1 from the power, first power. Derivative inside is 1, so that's just that. Times the second guy, which is 4x minus 3, right? And the first guy is x minus 3 squared, and multiplied by derivative of 4x minus 3 is 4, right? Right, then we can pull out, let's see what's in common, right? So you already have 2, but you can see that you have a 2 here, and a 4 is 4 is 2 times 2, so you can pull one of them out, right? So you have an original 2 and another 2, so it's going to be 4, right? Then you have x minus 3 here, and there are 2 of them, so I'll just take one of them. So we pull out x minus 3, right? Then we just have to kind of collect leftover. So you have 4x minus 3, and that takes care of this guy, right? Then what's left here is 2 times x minus 3. So that's going to be plus 2x, and 2 times negative 3 is negative 6, right? Then we can just clean it up, so because we took care of everyone there, right? So this is going to be 4 times quantity x minus 3, and then you have 6x minus 9, right? And since 6 and 9 has both of them have 3 in it, so we can pull that out. 3 times 4 is 12, x minus 3. Right, if you pull 3 out, so you have a 2x and minus 3. Alright, we got that. Alright, then we set this guy equal to 0. Alright, then you can see that this is going to give us, let's see, I'm going to go down here. Alright, x is going to be equal to either 3, or here it's going to be 3 halves. Alright, 3 halves. Alright, then we have to make sure that there's actually an inflection point there. So I'm going to just do the number line here. X, alright, so you have 3 halves, and then you have 3 there. Alright, then we're going to look at the sign of f double prime. Alright, so we can try something less than 3 halves, so we can try 1. Something between those two guys, we can try 2, and bigger than 3, we can try 4. Alright, so sign of the second derivative is going to be, I'm looking at this guy right here. Alright, so if you plug in 1, alright, so 12 is positive, 1 minus 3 is negative, and the 2 minus 3 is negative. So positive times negative is positive. Right, so if you try 2, 2 minus 3 is negative, 12 is of course positive, and 4 minus 3 is positive, so positive, positive, so that's going to be negative. Right, so if you plug in 4, positive, everyone's positive, so we have that. Right, so since the sign changes, so there's going to be a concavity change. So we're going to have an inflection point at 3 halves, so inflection point, and also at 3 you're going to have another inflection point. Alright, so let's type that guy in. Alright, so it's going to be at here, right, 3 halves and also 3. Alright, let's check the answer. Alright, we got that. Alright, what's the next question? On what interval is f increasing or decreasing? Alright, so let's go back to the first derivative. Here, if you look at the original function, right, based on the given sign, so first derivative is negative, so this means that it's a decreasing here, and positive, so it's an increasing here, and here it's still positive, so increasing here. All right, so it's decreasing up to 3/4 and increasing after that. All right, so here, all right, so it's going to be increasing on I'm going to do 3/4 and to infinity, right? So infinity, and I'm going to actually put the since we can include the bracket here, and decreasing up to 3/4, so it's going to be negative infinity to 3/4, right? Including that. All right, so let's check the answer. All right, interval which is increasing, create a sign chart. Okay, maybe they didn't like the technically it's okay to include it, but maybe I'll make sure that I'll try this and see if it'll take the answer. All right, so they didn't like the fact that I'm having that. Let's see, maybe say increasing on what intervals. All right. You can include 3/4, but I guess this system doesn't like that, so let's put the open intervals there. All right, and on what interval f concave upward and downward. All right, so let's go back and look at the second derivative. All right, so second derivative, since the second derivative is positive, so you have a concave upward up to 3/4. Or actually 3/2, and between 3/2 and the 3, you're going to get the concave downward, right? And after 3, you're going to get the concave upward, right? So let's type it in, right? So concave upward, right, from negative infinity to 3/2, and also 3 to positive infinity, and a concave downward in between. So it's a 3/2 and a 3. All right, so let's check the answer. All right, we got that. All right, so last one, we have to pick the picture. All right, so let's look at the increasing decreasing behavior. Remember that you have start out the decreasing and increasing and increasing. So which one has that behavior? All right, so here, all right, this one start out increasing, so decreasing, increasing, but decreasing here. So this is not going to be it. It's not even decreasing. So this one, decreasing, increasing, increasing. So we didn't even have to look at the second derivative. D is the correct answer. All right, so let's check the answer. All right, got that. All right, that's it. I hope that this was clear.